To determine the oxidation number of chlorine in this neutral compound, this rule becomes very essential for us, as the rule states that the sum of oxidation number is 0 for a neutral compound. Sodium chloride is a neutral compound. So we can use this same rule to find the oxidation number of one of these atoms in the neutral compound. So let's use it to find the oxidation number of, say, chlorine in this neutral atom. So based on the rule, it states that the sum of the oxidation number of this neutral compound equals 0. So that means the oxidation number here equals 0. So to find the oxidation number of chlorine, we use this and equate the summation of the oxidation number of sodium plus that of chlorine to give us equal to 0. So what we'll do is we'll say oxidation number of sodium plus the sodium plus the oxidation number of chlorine. According to the rule, it says it equals 0. So what is the oxidation number of sodium? We know it to be plus 1. Now, since we are looking for the oxidation number of chlorine, we will say plus X, which stands for our unknown, which will now sum up to equal to 0. So the next thing we do is we move this plus 1 to the other side since we are finding X. So based on our knowledge from mathematics, it's basic that whenever a sign is crossing the equal sign, it changes to negative. That means we'll have X now equal to this plus 1. As it moves across the equal sign, it becomes minus 1. So that means the oxidation number of chlorine is equal to minus 1 in sodium chloride. So you see, this rule is essential in finding the oxidation number of one of the atoms in your neutral compound. And this is very important, especially when we come to determining oxidation half and reduction half, which we will talk about in our next video. Do well to check up our next video on balancing redox equations. So this how we apply this very rule in finding the oxidation number of one of the atoms in a compound. So let's move to the next one. And the next rule states that the sum of oxidation is equal to the net charge for a polyatomic ion. And let's have an example to illustrate this. Now, in dichromate ion, this sum of the oxidation number of this ion is equal to the charge on it. That means this dichromate ion has an oxidation number in total to be equals to minus 2. And just like we've seen in the third rule, this also is important in determining the oxidation number of one of the atoms in this ion molecule. Now, take for instance our chromium. Now, if we want to determine the oxidation number of this guy here, we can use this rule to determine it, since we know that the sum of the oxidation number of the atoms in the ion will be equal to the charge on it. We can just break it just like we did in rule number 3 to find the oxidation number of the guy here. So let's see how it works. So we are looking for the oxidation number of this, so we make it to be X. So oxidation number of chromium here is X. However, we have 2 atoms of chromium. So that means it's going to be X times 2, not plus 2. So that means the oxidation number of oxygen is minus 2. So picking it up here, oxidation number of oxygen is going to be minus 2. However, we have 7 atoms of oxygen. So that means we are going to do minus 2 times 7, which will now be equal to minus 2. This charge on it, based on the rule, the oxidation number of a polyatomic ion is equal to the charge on the ion. So the sum of this oxidation number of individual atoms in the polyatomic ion will now be equals to the charge on it, which is -2. So don't forget, we are trying to find the oxidation number of chromium in this equation. So since we have it now, let's go ahead to simplify our equation. X times 2 will now be 2x. Now let's open this bracket. -2 times 7 will be -14, which will be equal to -2. So we are looking for 2x. We are looking for our x here. So what we do is we move -14 to the other side such that we find our x. So moving -14 to the other side will now change to positive sign. That means we'll have 2x will now be equal to -2 plus this -14 now changes to +14. So we simplify our equation. Now we have -2 plus 14 will give us +12. So since we are finding x, we divide both sides by 2. So this x goes with this. Then when we divide +12 divided by 2, we'll have +6. So that means the oxidation number of chromium in dichromate is +6. As I said, this will be beneficial when we come to determining which one is our oxidation half and which one is our reduction half in balancing redox equation. So I will say it again, do well to check up our video on balancing redox equation. So in a nutshell, we've come to the end of this video. Thank you.